Right, welcome to exercise 14D. I'm going to start with number 2 because we've already done number 1. It says that a large number of open cardboard boxes are to be made, and each box must have a square base and a capacity of 4,000 cubic centimeters. So if I draw this box, it would look something like this. It has a square base. It must have flaps on the edge which have to fold upwards because it's an open box. There's no lid on top. And if we make this side x and that side x, that will be a square, and we'll call the little flap heights h. So now we can express the volume of this box. Remember, volume is length times breadth times height, so that would be x times x, which is x squared, and times the height, which is h, and we know that that must be 4,000. So there's an expression for the volume of the box. Okay, the area of this box would be expressed by saying this area of the base, which is x squared, and then the area of these 4 flaps, each of those are x by h, okay, or x times h. So there are 4 of them, so 4xh. Now we want to differentiate this area function because it's the area that we want to find the minimum for. But the problem is that we have an x and an h variable in there. However, we can use this volume equation, which has an x and h in it, and we can rewrite the h as 4,000 over x squared. That means we can replace that here, and we're going to do that. So we get that the area is x squared plus, and that gives me 16,000 over x if I replace that value in there. Now this can then be differentiated, so we can say that the area differentiated is 2x minus 16,000, because that's x to the minus 1, so that minus 1 would come to the front, and it'd be x to the minus 2, or over x squared. So setting this to 0 because we want to find a minimum or a maximum, and remember that occurs where stationary points are or where the gradient function equals 0. So that means that 2x cubed minus 16,000 all over x squared must be equal to 0 if I find a common denominator. Okay, and that's just rewriting this as over x squared first and finding the common denominator. But of course only the numerator can ever be equal to 0, so therefore we can write that 2x cubed minus 16,000 must be equal to 0. Solving that gives me that x cubed is equal to 8,000, and that means that x is equal to 20. And if I use that value of x is equal to 20 to go and find the dimensions of the box, I'll find that the box has a base of 20 by 20, which is 400, and since the volume was 4,000, I'll have to times the height by 10 to get 4,000, and so the height was 10. There we go, we've done question number 1. Right, question number 2 is the one on the cylinder, and we have a cylinder that's cut from a solid sphere of radius r. Given that the cylinder is a height of 2h, find its radius in terms of h, and then show that the volume is given by that formula that they give in the textbook, and then they want to know what the maximum volume is. Well, the first thing that I notice, okay, is that if I join the center of the sphere to the center of the radius line at the top of the cylinder, I'd create a Pythagorean triangle. And this is the height, or the value h, because remember the height of the entire cylinder is 2h, so that's from the center to the top there will be half that, which is h. This is r, and this is 3. So if I were to express the radius in terms of the height, I could say that the r is equal to the square root of 9 minus h squared. This is simply from Pythagoras. Remember, r squared plus h squared will be equal to 9. Okay, if you square all of those things. So therefore r is the root of 9 minus h squared. Now what is the volume of a cylinder? Well, a normal cylinder, any cylinder, is simply pi r squared h. But in this cylinder that we have, the h is 2h. And we've still got pi and the r squared. Well, if I take this r here and I square it, I'll just get 9 minus h squared. Okay, and if I look at how that looks now, that looks exactly the same as the formula that they gave us. And now we found the volume. Right, so next we're going to move on and we're going to use this formula because they want to say what is the maximum area, or sorry, volume of this cylinder. So the maximum volume will occur where the derivative of the volume formula is equal to 0. Well, for that we'll have to just rearrange this formula a little bit more and multiply it out. So we're going to multiply this in here into both terms. So we've got 18 pi h and minus 2 pi h cubed. Okay, so that is my volume. Deriving that, I'll get 18 pi, and I'll get minus 6 pi h squared. Okay, and of course we've got to set that to 0, and so we'll make that equal to 0, and then go and solve for the h. Well, that means that the 18 pi is equal to 6 pi h squared, and that means that h squared is simply 18 pi over 6 pi. And of course that means that h is the square root of 18 over 6, which is simply 3. The pi's cancel, so root 3. There we go. Now we found a value for h. Now we can use this value for h, and we can put this back into our volume formula over here. Okay, and that will give us the volume, or the maximum volume. So let's use that as 18 pi h minus 2 pi h cubed. 18 pi h minus 2 pi and we're going to put in root 3 both into these h values to get our volume. So 18 root 3 pi, or 18 root 3 pi minus, now h cubed would be root 3 times root 3, which is just 3, so that'll be 3 root 3, and times that by 2 we get 6 root 3 pi. So what's 18 root 3 pi minus 6 root 3 pi? It is simply 12 root 3 pi. Okay, so 12 root 3 pi is our volume, and there we have it. Let's have it there. 12 root 3 pi. Great. So that gives us number 3, and you can go and work that out as a decimal if you want to, but you don't need to. That should be sufficient for the answer. Right, so number 4 says that a variable rectangle has a constant perimeter of 20 centimeters. Find the lengths of the sides when the area is maximum. Okay, so variable rectangle, constant perimeter of 20. We don't know what the rectangle looks like, but it's going to be like that. So if we just choose one side to be x, we know the opposite side of a rectangle will be the same. Okay, but what will be the side over here? Well, we know we've got 20 to play with, so we've taken away 2x, so 20 minus 2x is left, and of course these two sides are all equal, so one of the sides will be half that length that's left. Okay, so there we've got our rectangle with its two sides. Now we must work out the area of this rectangle. So area is just length times breadth, so we go x, 20 minus 2x over 2. Okay, and if we multiply that x in, we get 20x minus 2x squared all over 2, which we can reduce to 10x minus x squared. Okay, so there is an expression for my area of my rectangle. But what are we going to do with the rectangle's area? Well, we want to prove that we get a maximum for the area. That means we have to set the derivative equal to 0. So the derivative of area will simply be 10 minus 2x. And if I make that equal to 0, which we have to for the maximum, we'll solve for the x, and x comes out to 5. Now if we use that x equals 5, we can see that actually this rectangle is not just a rectangle, but it is actually a square. Because remember, if I've got 5 here and 5 over here, that's 10. We only had 20 to play with, and the other two sides must be equal, so we've only got 10 left. They must also be 5. And so we proved that the maximum area occurs when that rectangle is actually a square. Alright, so question number 5 is not much different to that, except that this time they gave us an area. And they said that the constant area is 35 centimeters squared. What is the length of the sides when the perimeter is a minimum? Right, so we have a rectangle that we know is 35 centimeters squared. Now, we don't know the sides, but we know that that one must be x, just choosing it to be x. But if that is x, what must this one be? Well, it has to be 35 over x, because if I times x by 35 over x, I'm going to get 35. Does this make sense? If that's true, we've got our length and our breadth now, and so we know that perimeter can be given by 2 times the length, which is 2x, and 2 times the breadth, which is 70 over x. Okay, and if I want to find where the perimeter is going to be a maximum, I must do a derivative equation again, and so I'll set that to 0. So let's say the derivative, which is simply 2, and 70 over x is 70x minus 1, so that'll be minus 70x to the minus 2, and I can also write x to the minus 2 as over x squared, so I'm going to do that over there. Let's just erase this here. Alright, so if that's equal to 0, finding a common denominator again will give me 2x squared minus 70 must be equal to 0 for the top numerator. Right, so that means that what is x squared? Well, 2x squared equals 70, that means x squared is 35, that means x is equal to root 35. And if I go and check back at my shape, if it's root 35, and then the other side will be 35 over root 35, which is also root 35, again, the maximum area here will be when it's a square, or the maximum perimeter, sorry, will be when the shape is a square, the minimum perimeter, sorry. Right, so we're on to number 6 now. And number 6 says that there's a curve ax squared plus bx plus c. That's obviously some kind of parabola. It crosses the y-axis at the point 0, 3 and has a stationary point at 1, 2. And we must find the values of a, b and c. Well, firstly, if I substitute the point 0, 3 in, okay, 0 is the x value, I'm left with y is equal to c, and obviously that y is 3, so the c must be equal to 3. So the point is very quickly identified that c equals 3. I also know that there's the point 1, 2 at which there's a stationary point. So that means if I derive this equation, which would come out as 2ax plus b, that must be equal to 0 when x is equal to 1. So if I put in x is equal to 1, I get 2a plus b, and that simply equals 0. Now that's still not enough to solve this equation, because we've got an a and a b variable and we've only got one equation, but we can use the point 1, 2 in the original equation as well, okay, because it's a point on the curve. So that means that I can say that 2 for the y value is equal to 1 squared times a, which is just a, plus 1 times b, which is b, plus c, which we already knew was 3, okay, and so that gives me another equation, which is that a plus b is equal to minus 1. Let's just erase this over here and write a plus b equals minus 1. Okay, and now I can just do a simple subtraction. 2a minus a is a, 0 minus minus 1 is plus 1, so the a comes out as 1. And if a is equal to 1, 1 plus what equals minus 1, the b must be minus 2. There, I've got my 3 answers. Okay, for a, b, and c. Right. Question number 7 says that the gradient of the tangent of the curve is y is px squared minus qx minus r. Px squared minus qx minus r. So if y is equal to px squared minus qx minus r, at the point 1 minus 2, the gradient of the tangent is 1. So that means, again, if I derive this equation, y prime is 2px minus q. this derivative must be equal to 1 at the point 1 minus 2, or where x is 1. So that means that 2p minus q equals 1. Should put a therefore sign. Okay, there's my first equation. Now it says that if the curve crosses the x-axis where x is 2, okay, the curve crosses the x-axis where x is 2, that means that the point 2, 0 is on the curve. Okay, well, if I put in 2, 0 into the original equation, I'm going to get the 4p minus q, sorry, 2q, because it's 2 for x, minus r will be equal to 0, because the y will be 0 at that point. Okay, so that's helpful. But I've also got another point. I've got the 1 minus 2, so I can put that in as well, and I can say that minus 2 for the y must be equal to p for times 1 minus q minus r. Okay, so now it's these bottom two equations that I'm firstly going to subtract as simultaneous equations so that I can get rid of the r's. Okay, so 4p minus p is simply 3p, minus 2q minus q is minus 2q plus 2q, which is minus q, and the minus r minus the minus r makes minus r plus r, which is 0. 0 minus 2 is 2. So I've got an equation that says 3p minus q is 2. I'll use this equation now that I found earlier together with this one. So 3p minus the 2p is simply p. The q's will disappear, and 2 minus 1 is 1. I get a value for p is 1. Okay, put that value back into any equation. We'll do it here. 3 times 1 is 3, minus the q is 2. So what must I subtract to get to 2 from 3? The answer is that q will also be equal to 1. Okay, and if I put that back in here, I can get 1 minus 1, which is 0, minus r must be equal to 2. Okay, so 0 minus what is equal to 2? And the answer is, it must be minus 2 for r. There we go. So now we've got 3 values for p, q, and r. They also want us to find the other point of intersection with the x-axis for this curve. So let's go and put all these values into the original curve and see what it looks like. Okay, I'm going to go up there. We've got 1, 1, and minus 2. Okay, so here was the original curve. Let's work from here. 1, 1, and minus 2 for q. That means that my curve is x squared minus x and minus 2. Let me just go back here quickly and check. We said that r was minus 2. Sorry, this was equal to minus 2 here. That's why r is actually equal to positive 2. Okay, and that's, if r is positive 2, we've got minus r, which is minus 2 at the top. Just make that little correction there. Okay, so there's my equation, x squared minus x minus 2, which I can factorize very nicely as x minus 2, x plus 1. That gives me the value minus 1 for x and 2 for x as the two places where it cuts the x-axis, because that's where it'll be 0. Okay, and of course we know that the one is 2. We were told that originally, so the other one is the minus 1. They then ask us to sketch the graph. Okay, so this is a parabola that will cut at minus 1 and at 2. It's a positive parabola. We don't know where it turns, but we can safely assume that the value must be halfway between the minus 1 and the 2. Okay, and that value would be a half over here. Now if x equals a half, we can fill in a half into the equation to find a y value. A half squared is a quarter, minus a half is a minus a quarter, and minus 2 is 2 1/4. So there we go, we get minus 2 1/4. You could have also found this value because it is the axis of symmetry, which happens at minus b over 2a. Okay, that's something you learned in earlier chapters in our algebra. And so there we've got the sketch of that curve, right? Well, we're on to the last question, which is question number 8. Now, it says that y is a quadratic function of x. That means it must have a formula, ax squared plus bx plus c. That's my y formula, okay. They also tell me that the line y is 2x is a tangent, okay. And so the line y equals 2x has a gradient of 2. So the tangent must have a gradient of 2 when the point is touching the point 3, 6. Alright, so if I derive this again, I get 2ax plus b. That gradient is equal to 2 when the x value is 3. So therefore I'll make this 6a plus b is equal to 2. That's one equation, okay? Then they tell us that the turning point on the curve happens where x is minus 2. So that means that for the same gradient function here that I had here, okay, it's equal to 0 when x is minus 2. So let's put in minus 2 for x here. We get minus 4a plus b, and now it will be equal to 0. Well, there I've got two answers, or two equations. I can go and solve for the a's and b's. Let's go and do that quickly and see what we get. Alright, well, if you subtract, you get 6a minus 4a, which is 10a. And 10a will be equal to 2 minus 0, which is simply 2. That means a is equal to 1/5. Well, if a is a fifth, we can put that back into one of the equations here. 6 times a fifth is just 6/5. And b, we don't know, but 2 is the same as 10/5. And therefore we can see that b must be 4/5. Alright, that doesn't give me my c value yet though, so we've still got to go and work that out. So let's go back up here and see what the equation looked like. Okay, there was my general equation, and we said that a was a fifth, so we know that a fifth x squared plus 4/5 x plus c must be equal to y. Now, do we have a point that we could use here? Well, yes, we can still say that the point 3, 6 occurs on this curve as well. So that means that 6 must equal 9/5. 3 times 3 is 9, and times the fifth is 9/5, plus 12/5 plus c. And if I rearrange that, 9/5 plus 12/5 is 21/5, but 6 is 30/5, so I'll get 30 minus the 21, which leaves me with c equal to 9/5. So there is my c value, 9/5. So I can write my equation as that, or I can multiply the whole thing by 5 and say that 5y is equal to x squared plus 4x plus 9. There we go. And that's an expression for the curve. Right, well, that takes care of exercise 14D. So I'm sure you're all happy to see how those all work. I'm going to move on to the mixed exercise 14 now. Okay, so in mixed exercise 14, question number 1 says, find the gradient of a curve with the equation y equals 6x squared minus x. Okay, so y 6x squared minus x at the point where x is 1. Gradient function will therefore be 12x minus 1. And they told us that x is equal to 1, so we'll put in 1 there. 12 minus 1 is 11. So the gradient of that curve, or the gradient of the tangent, will be equal to 11. Then they say find the equation of the tangent at this point. Okay, so if the equation of the tangent must be that of a straight line, y equals mx plus c, we already know that the gradient is 11, so we know that y equals 11x plus c. To solve for the c, we're going to need a point. We don't have any points given to us, but they did tell us that x was 1. Okay, so then I can go and find what y is by plugging it in here. So 6 minus 1 is equal to 5, so that is 0.15 is one of the points on this curve. We'll use this point over here and say that 5 is equal to 11 plus c, making c equal to -6. And therefore I can say that the equation of the tangent at that point is 11x minus 6. Now it says, where does this tangent meet the line y equals 2x? Well, that will mean that those two lines must be equal. Okay, so we're going to make the line y equals 2x equal to the y equals 11x minus 6. And that means that 2x equals 11x minus 6, which means that minus 9x equals minus 6, or x is equal to minus 6 over 9, which is 2/3. if x is 2/3, let's put that into the y equals 2x equation. 2 times 2/3 is 4/3. Okay, so the y value would be 4/3. So this is the point. 2/3 of 4/3 is the point at which they meet each other, where the line 2x meets the tangent that we have drawn. Okay. Right, okay, so that's question number 1 of 14, or mixed exercises. Number 2 says find the equation of the normal to the curve. Y is 1 minus x squared. So let's write the equation. And we're going to need the normal, so we're going to definitely need the gradient function here. So y prime here is 0 minus 2x. That's my gradient function. And they said at the point where the curve crosses the positive x-axis. So this curve 1 minus x squared, we want to know where it crosses x. Well, 1 minus x squared can be factorized as 1 minus x, 1 plus x. And so the values for x that would make this 0, 0 being the y value, and that will be on the x-axis, would be 1 and minus 1. So clearly the value that's positive is the positive 1. So we must plug in positive 1 into this equation. So we see that the gradient here would be minus 2. Okay, so now we know that the equation of the tangent would be minus 2, but then what would the equation of the normal be? Remember, a normal, 90 degrees to a gradient of minus 2 would be a gradient of a half, because the product has to be minus 1. So we know that our normal has a gradient of a half. The equation of that normal would have to be this. But now we need a point on the graph. Okay, well, we know that this point is happening at the point where x was 1. So if I put in 1 into the curve, I get 0. Okay, and so therefore I can see that y is equal to a half, or 0 is equal to a half times 1, which is a half, plus c. My c comes out as minus a half. So here is my final equation. A half x minus a half. Y equals a half x minus a half. And they also said we must find the coordinates of the point where the normal meets the curve again. Alright, so that means that I must use this equation and solve it here, and by putting it into making it equal, because when they equal they will cut each other. So let's use the half x minus a half, and we say half x minus a half must equal 1 minus x squared. Take everything over, we get x squared plus a half x, and minus a half minus 1 is minus 3 over 2 is equal to 0. I can rewrite this as 2x squared plus, sorry, that's a half x, plus x minus 3 is equal to 0. Alright, if we factorize that, we get 2x plus 3 x minus 1. Let's see, plus 3x minus 2x gives me the plus x. That's correct. We know that x is 1, and we saw that earlier, but the other value for x would be minus 3 over 2. Minus 3 over 2 to make it 0. So once I factorize that, then I can solve for that, and the coordinate for that point will therefore be, if I put x is minus 3 over 2 into one of the graphs, okay, I can put it into 1 minus x squared. Well, if minus 3 over 2 is the x, that means it's minus 9 over 4. Okay, so what is plus, it's minus 9 over 4, plus 9 over 4, but it becomes minus because of the minus outside. So 1 minus 9 over 4 will give me minus 5 over 4. Let me see, let's check that, sorry. 1 minus 9 over 4. Well, that's 4 over 4 minus 9 over 4, yes, which is minus 5 over 4. And there we go. That is my other point for where the normal will meet the curve. Question number 3 says find the coordinates of the points on the curve y equals x cubed plus 3x, where the gradient is 15. Alright, so if y equals x cubed plus 3x, the gradient function must be 3x squared plus 3, and we'd want the gradient to be equal to 15, so we'll make this equal to 15 and solve. Alright, that means that x cubed plus 1 must equal to 5. Okay, I can factorize 3 out, or I can say minus 5 is equal, x squared plus 1 minus 5 is equal to 0. And that means that x squared must be equal to, or x squared minus 4 equals 0. Well, if x squared minus 4 is 0, that's just a difference of squares, which is x minus 2x plus 2. So the 2 points at which that will happen, okay, are 2 and minus 2. And if I put 2 and minus 2 back in here, I get 2 cubed, which is 8, plus 3 times 2, which is 6, okay, and 8 plus 6 is 14. So 2, 14 is one of the points, and if I put in minus 2, I get minus 8 and minus 6, which is minus 14. So minus 2, minus 14 is the other point. There we go, that's number 3. Okie dokes, so we're going to do number 4 now. Find the equation of the tangent to the curve x cubed minus 6x squared. Let's write that here. Minus 6x squared plus 12x plus 2. Okay, so they want the equation of the tangents to the curve that are parallel to the line y equals 3x. Okay, or in other words, have a gradient of 3. So there are some tangents that have a gradient of 3 for this curve. Alright, so let's write our derivative, which is 3x squared minus 12x plus 12. And we know that this must be equal to 3. Okay, so let's make that equal to 3. I'm actually going to factorize the 3 out in a moment, but let's just put the 3 here. 3x squared minus 12x plus 12. And if we do that, let's move this up. So 3 is equal to, let's make it now 0, 3x squared minus 12x, and we'll say 12 minus 3, which is plus 9. Factorize 3 out, and you've got 3x squared minus 4x plus 3. That can also be factorized as x minus 3 and x minus 1, and that simply gives you that x is 3 or 1. So these are the 2 places for x where we will have gradients of 3 or tangents of 3. Okay, so they wanted the actual equations of these tangents. So let's go and solve for those values where x is 3 and x is 1. Alright, I'm going to move up here a little bit. Okie dokes, so let's write here quickly. X was equal to 3 and x was equal to 1 are the points where this will occur. So we'll need to actually put those values back into the equation to get actual points for the y. So if I put 3 in, I'm going to get 3 cubed, which is 27, minus 6 times 9, which is 54, that's minus 27, plus 36 plus 2, which is plus 38. Okay, so minus 27 plus 38 gives me 11. Okay, so there's 311 is one of the points. If I put in 1, I get x cubed, which is 1 minus 6 plus 12. So 1 minus 6 is minus 5, plus 12 is plus 7, plus 2 is 9. So there we go, 1, 9 is the other point at which the tangents occur. Okay, now I've got to get the equations of the tangents. Both of these will have to have a gradient of 3, so we know that our formula is 3x plus c. Okay, and we can use the 2 points to put them in here. Okay, so let's do that quickly. Y equals 3x plus c, so that is 11 is equal to 9 plus c. That means the c comes out to 2, so one of the equations is y equals 3x plus 2, and then the last one, if I put in the 9 in the y, I get 3. 3 plus 6 is c, so the c comes out as 6, so y equals 3x plus 6 is the other equation. Okie dokes, so there we go. I'm going to do the last couple of questions in another video because this one's going on quite long now, so let's do that.